Okay, today we are going to take a look at inverse functions. Let's start with a review. So you are given this relation, and I want to know what is the domain and the range of this relation. If you recall, the domain goes with our possible x values of a function, and the range goes with our possible y values. So in this function, my domain would be my various x values: 4, 6, 12, 8, and 2. My range, my y values: 5, 7, 20, 3, and you don't have to list 7 again. The definition of what an inverse function is: the inverse of a function is found by reversing the order of the elements in the ordered pairs. In other words, switch x and y. That's all we do. So if I'm looking at that relation above and I switch x and y, my coordinate 4, 5, the inverse of that would be my coordinate 5, 4. So keep going with that. Example 1. Let's complete the diagram at the right using this relation. So as I look at that relation, my domain is my set of x values: 0, 2, 4, and 8. My range is my list of y values: 1, 3. I don't need to relist 1 or relist 3. The inverse of that, I merely flip-flop or switch my x and y. So what that means is my range is now my domain, and my domain of my original function is now my range. Okay, let's look at example 2. I have relation t here on the left, and on the right, I want to do the inverse of relation t. So if I flip-flop my x and my y, if x is -4, y is going to be 1. If x is -3, my y value is 2. If x is -3 in this next row, my y value is 3. Now we're going to plot those. And this is where I want you using 2 different colors, okay? Or maybe a colored pen and a pencil when we graph relations and their inverses. So as we look at the packet, we need to see 2 different colors. So I'm going to asterisk or do my key. So relation t, if I plot those points, 0, -5, 1, -4, 2, -3, and 3, -3. Okay, we're not going to connect them. We're just plotting those points. It's a discrete relation. And then I've got my inverse, which I'm going to do in a separate color. So now it's -5, 0, -4, 1, -3, 2, and -3, 3. A graph of a function or a relation and its inverses are actually reflections over the line y equals x. So notice those graphs, they are mirror images of each other on opposite sides of that line. And that's going to help me determine if I graphed my inverse correctly. Okay. So now they're asking for the inverse as we look at example 3 of the function y equals 2x plus 8. So to find my equation, I first switch the x and y values. So I keep my equation the same. I replace y with x and x with y. Now they want me to solve for y. So I got to get y by itself. To do that, I'm going to subtract 8 from both sides first. So then we have x minus 8 equals 2y. Dividing both sides by 2. How we write that is y equals x over 2. Think of that as 1x over 2, which would be 1/2 x, and negative 8 over 2, which would be negative 4. Okay, so they're asking us to graph both of these functions. I'm going to graph my inverse first. Okay, I did that one in purple. That's in slope-intercept form. My y-intercept is negative 4. And my slope is a positive 1/2. So up 1 over 2, up 1 over 2, up 1 over 2. Ideally, we're using a ruler or a straight edge to connect these. Let me redo that. There we go. And then I'm also going to graph my original, so I'll color code that. Well, that technically has a y-intercept of 8, but I can't fit that on my graph. So something that I could do is, I knew the inverse had the point 0, negative 4. So if that's the case, then my original function would have the coordinate negative 4, 0. And I can use my slope of 2 to go from there. Up 2 over 1. Up 2 over 1. Up 2 over 1. And notice if I kept going, I would get to that 8. Okay, I'm just going to put this in here, this y equals x, roughly with a dashed. Okay, I have to use my finger on the screen here, so it's a little tough, but are they reflections over that line? I'd say it looks pretty good. Okay, your assignment is pages 5 through 6, but we are going to do a couple of those together. So let's take a look at page 5. For some reason, the top of my screen disappears here. Let's see if I can bring it back. There it is. Okay, so I'm going to start with number 4. Okay, that's pretty similar to what we were just doing. So the first thing I'm going to do is I'm going to find the inverse of that function. So my directions, maybe we should go back up and read that. Find the inverses of each relation. So if it's in a table, we flip-flop our x and y, and when we graph these on 1 and 2, we're just going to have points. But for these down here, we're actually going to connect them. So you'll notice 3 and 4 are both linear functions. 5 and 6 are both quadratics, and the shape of our quadratics are parabolas. But let's take a look at number 4. So to write the inverse of the function, I'm going to flip-flop my x and y. So then I have x equals 4 minus 3y. I would like you to pause this and get y by itself. You would subtract 4 and then divide by negative 3. So then you would have y equals negative 1/3 x plus 4/3. Well, my y-intercept is 4/3. I can't really graph 4/3 exactly. So let's start with graphing our original function. Y equals 4 minus 3x. My y-intercept is 4. And my slope is negative 3. So down 3 over 1. This is really hard to do with my fingers, so it's easier for you on your paper. Down 3 over 1. Okay, well, because I can't really exactly graph 4, 3, I'm going to find a point on my original function and then flip it. So I'll graph this one in, I'll do purple. This point right here was 0, 4. The inverse of that would be 4, 0. 1, 2, 3, 4. So I'm going to start with that point. And then I can use my slope of negative 1/3 from there. So down 1, 3 to the left. Or I could have gone up 1, 3 to the right. Oops, I did a positive slope. Miss K. Ugh. I went down and left. I should have gone down and right. Darn it. Okay, let's start at 1, 2, 3, 4, 0. Down and right. 1, 2, 3. I knew it didn't look right. Up and left. Because 1, 1 would still be 1, 1. Okay, that makes sense. There we go. That makes more sense for a reflection over the line y equals x. The other one we're going to take a look at is number 6. What happens when your original graph is a parabola and you need to take the inverse of it? Okay, as you can recall, y equals x squared is our parent function. That's where we plotted 0, 0, and then we went over 1 up 1, over 2 up 4, over 3 up 9, and did a reflection on both sides. This function is my parent function shifted 2 to the right. Okay, so I'm just going to write that down. We go right 2. So my starting point was 0, 0. And if I go right 2, my starting point is now 2, 0. So I'm going to graph this one in this purple color. So I'm going to go over to 2, 0. And then from there, over 1, up 1. It's really hard for me to see when I'm using my fingers. And then over 2, up 4. Over 3, up 9. My ability to connect those, yours should be better on your paper. All right, now we need to flip-flop x and y. So now we have x equals the quantity y minus 2 squared. I got to get y by itself. The first thing I have to do is square root both sides. When you square root both sides, you have to remember the plus or minus. So then I have plus or minus square root of x equals y minus 2. One more step to get y by itself is to add 2 to both sides. So then I have y equals plus or minus the square root of x plus 2. Oops, I should make that clear that that plus 2 is not under the radical. Maybe I should have wrote it out in front. Well, we don't really know how to graph the square root x function, so let's just think about our original parabola. I want it to reflect over the line y equals x, okay? So if I draw that line in, it reflects over that. So in my other color, I'm going to use green for this one. What originally was my starting point, 2, 0, I'm now going to start at 0, 2, okay? I find the inverse of my starting point, so 0, 2. Now, think about turning your paper 90 degrees counterclockwise, okay? So it's kind of like you're shifting it, so the side is now the top. So make your parabola from there. So over 1, up 1, over 2, up 4, over 3, up 9. We will talk later in this unit about how this relates to the actual square root of x graph. This plus or minus is where we're getting both sides of it. Okay, so that should help you as you do the other parabola graphs. So your task is to finish the problems on pages 5 and 6 that we didn't do together, and then check that from Canvas. Good luck.